In this video, we'll look at writing of ionic formulas. Ionic compounds are made by combination of metals and non-metals. So how can you identify this is a metal and this is a non-metal? You need a periodic table for that. So let's get our periodic table. Now, let's use our periodic table to identify metals from non-metals. So we use this zigzag line or this staircase. So this zigzag line separates the metals from the non-metals. To the left of this zigzag line on the periodic table are metals, and to the right of the zigzag line are non-metals. So if you have a combination of metals and non-metals, you will form uh, ionic compounds. So now, when the metal atoms combine with the non-metals, the metal atoms become positively charged and the non-metals become negatively charged. So positively charged ions are called cations and negatively charged ions are called anions. And when you're writing your ionic compound formula, the positively charged ions are always written first. That is, the cations are always written first. So if I have a metal A and I have a non-metal C, just giving an example, I'm not saying that A is an element, it's a chemical symbol of an element on the periodic table. No. So if I have a metal A, which is a cation, maybe it's positively charged, and a non-metal, which is negatively charged, I will write the cation first, then the anion second. Okay, so now we have identified metals from non-metals and how we can write the ionic formula. We start with, that is, we start with the cation and anion. Let's look at how we can know the charges of the cations and the anions on the periodic table. Okay, so this column here has a charge of 1 plus. This other column, the second one, charge of 2 plus. So the charge of 2 plus is only for this column here. Then we have this section here. These are transition elements. We'll look at their charges in another video. Transition elements. Then this column, elements in this column have a charge of 3 plus. Elements in this column, well, the charges vary, but it can either be positive, negative, and we have this column here. The charge here is 3 minus, this other column 2 minus, this other column 1 minus. So you can copy these charges on your own periodic table for easy reference. So now that we have identified the charges of elements on the periodic table, let's look at examples of how we can write uh, ionic formulas. Okay, so let's look at the first example. Let's write the ionic formula of sodium chloride. Sodium is a metal. It's found in this column, in group 1 column. So sodium has a charge of positive 1. Then chloride, which is chlorine, is in this column where it has a charge of 1 negative. So how do we write the formula? You always start with cations first, like we discussed. You start with the cations first, which are the metal ions, then you end with the anions. All right. So we have our sodium and our chloride here. Is that it? No. So you need to ensure that the overall charge of the ionic compound should give you a net charge of 0. So here, if I have positive 1 plus -1 on the chloride, it should give me 0. And it has given me 0. So meaning that this is how we're going to write our formula. So then the other thing you need to keep in mind is that when you write your formula, the final uh, formula should not have any charges. So you are going to write it as sodium chloride. So should you indicate the ones? No, do not indicate the ones in your formula. You don't have to tell me to say this is 1 chlorine or 1 chloride, 1 sodium. It's going to cloud this formula, so we avoid writing the ones. But if there is more than one ion present, you can indicate if it's 2, 3, 4, and so on and so forth. Okay, so formula for sodium chloride ion will be written as that, and this is sodium chloride. Okay, now let's do another example. So in the next example, we've been asked to write the formula of potassium iodide. Potassium iodide. Potassium is here, symbolized by letter K, and it's in this column where it has a charge of +1. Okay, and iodine is in this column for nonmetals, uh, where the column has got a charge of -1. So how do we write this ionic formula? Remember, we start with the cation first, then the anion. So potassium, iodine, charge A positive, charge A negative. So we only need 1 potassium, 1 iodide. Then we're going to end it like that. So now let me simplify something for you. Rather than looking for how many atoms are needed so that the charge is 0 and so on and so forth, you can just simply swap these valences. So if I have a charge here of 1 and 1 there, 1 negative, 1 positive, 1 negative, 1 positive, I can simply swap them. So how do we swap them? Let's use letters. Let me say I've got Y, I've got Z there as our charge and valency. So the Z will come here. It will become a subscript of A. And then the Y will become a subscript of B. So your final ionic formula will be A with Z, B with Y. So this way it will be easier for you rather than looking for the number of atoms that will give you a net charge of 0. This is the easiest that you can do. So let's write this one. Potassium iodide, we have one there, 1 positive, 1 negative. So you can just swap. You have potassium iodide. Remember, don't indicate the charges and don't show the number 1 in the final ionic formula. Okay, so let's do another example. Next example is lithium nitride. Lithium nitride. So how do we write the formula of lithium nitride? Lithium is here. Okay, so we have lithium there, 1 positive. Nitride is nitrogen, which is here. So remember, the easiest way is just swapping them. No need of showing number 1 and no need of showing the charges. So you're going to have a 3 there and nitrogen. So this will be lithium nitride. Let's do another example. The next example is calcium oxide. Calcium oxide. So calcium is here. Calcium 2 plus. Then oxide is oxygen, which is here. So 2 negative. So remember, you can simply swap them. No need of showing the charges at the end. So you're going to have 2, 2. Now, when you have formula like this, where you can reduce these subscripts to their lowest terms, please reduce them to their lowest terms. So 2, 2, there's a common factor which is 2. I can reduce this to their lowest terms to give me calcium oxide. Remember, we don't have to show that there's one atom, one atom. We don't have to cloud the chemical formula. So whenever possible, if you can reduce the subscripts to the lowest terms, please do that. Do that to whole numbers, though. Don't reduce them to decimals. We don't want to say we've got uh, calcium, which is 0.7 atoms, ions, and oxygen, which is 0.2. No, they have to be whole numbers and not fractions or decimals. Okay, let's look at another example. So let's look at our final example, aluminium fluoride. How do we write the Ionic formula of aluminium fluoride? So aluminium is in this column, which is the group 3 column, and it's 3 plus. Then chloride is in this column, -1. So what do? We swap them. We don't have to show the 1, so we leave that. Then there'll be a 3 on chloride. So this is how you're going to write aluminium chloride. Okay. So if you've noticed something, we have just been looking at metals. We've just been looking at metals that are in these columns. First column, second column, and this column, which is called the group 3 column, this one here. What about elements in the middle section here? Elements they are called transition elements. So what about those metals? So we are going to look at ionic formulas using transition metals in the next video. So thank you very much. Remember to subscribe, like, and leave a comment in the comment section below. Stay blessed.